Hello, welcome to Start Afresh. Today's topic is uniform and non-uniform motion. You all must have heard the story of tortoise and hare, where we learned the lesson that slow and steady wins the race. Let's see the same story from science perspective. Tortoise remain in uniform motion, whereas hare motion was non-uniform. Let us assume distance need to be covered was 100 meter. Tortoise was moving with steady speed, but hare, who was initially fast, relaxed in between, lost to tortoise. Suppose tortoise took 20 seconds to cover the distance of 100 meter. Can we calculate the speed? As we know, speed is distance covered in per unit time. So 100 meters divided by 20 seconds makes it 5 meter per second. Not to forget to mention the unit meter per second. Other units like kilometer per hour or miles per hour can be used. We call this speed as uniform speed. Now, can we find the speed of hare? As in this case, motion is non-uniform. It will have different speeds at each instant of time, known as instantaneous speed. Odometer of vehicle shows this instantaneous speed. For complete race, the speed calculated will be known as average speed. It is total distance divided by total time taken to complete the race. It is as simple as uniform motion, but we need to mention average with it. Suppose time taken by hare is 25 seconds. So its average speed will come out 100 meter divided by 25 seconds, that is 4 meters per second. So is the tortoise faster than hare? Obviously not. If we take speed of hare at different instants, it would be more. The reason why hare lost the race is because of time spent during rest. Let's take another example. If you're going from point A to point B, which is 900 meters apart, and you took 3 minutes, can you find the speed you are moving with? You might do 900 meter divided by 3 as 300 meter per second. But this is wrong, as we need to convert the time to standard units of seconds. So 3 minutes become 180 seconds and speed become 900 divided by 180, 5 meter per second. If we draw the line graph between distance covered and time taken for both the animals, we can see graph for tortoise is straight line depicting equal distances covered in equal interval of time. On the other hand, for hare is non-linear. Here slope of the graph indicates speed, which is distance covered per unit time. Summarizing uniform motion, it's a motion when an object covers equal distance in equal interval of time. Distance time graph is a straight line and speed is constant throughout the distance. Examples of uniform motion can be tip of hands of wall clock, as hour hand takes 12 hours to return to same number, minute hand takes 60 minutes and second hand takes 60 seconds. Motion of a car can be uniform if we consider a road free from traffic. External factors which affect motion of car can be traffic, traffic light, crowded area, etc. To summarize non-uniform motion, it's a motion when objects cover equal distances in unequal interval of time or unequal distances in equal interval of time. Means we can keep one quantity constant and observe changes in other quantity. It is the most common type of motion that we can observe in our surroundings. Here, if you are driving your car in congested area, you perforce have to change your speed, which makes it non-uniform. Other examples can be walking, running, riding a bicycle, bouncing of ball, etc. As initially we have discussed, distance time graph for hare, its graph is non-linear. Last, we can see distance time graph for object at rest or stationary, as object is covering any distance even if time is increasing. It will be a straight line parallel to x-axis.